Hello, this is Mr. Wynn, and today's lesson is 6-2, Inverse Functions and Relations. So remember, inverses are obtained when you flip the x's and y's of all coordinates. So here I have a table, let's call this f of x, and it has the points negative 6, 7, negative 5, 1, negative 4, 4, 2, 8. If I reverse it, flip everything. So go over here, I reverse the x and y, so now it's 7, negative 6, and this negative 5, 1 turns to 1, negative 5, and so on and so on. This is what we call f inverse of x, the inverse of f, so f negative 1 of x. Alright, so if I look on a picture, on a graph, on this right side, the first table, f of x, is this black picture right here, and the second one, the f inverse, is this green picture right here. What do you notice about those two pictures? Well, you should be able to see that it is a reflection over the diagonal line y equals x. Right here, that goes to the origin. So it's a mirror image of itself. Alright, so the first thing you should be able to figure out is be able to identify inverses from a graph, in graph form. So looking at the following graph are the two inverses of each other. So we see as u, upwards u, and a sideways u. And you reflect it across the diagonal line, they do overlap. That is the mirror image. So this is a yes. And again, you could pick some points and see if it has a reflection, and it does. For example, right here, that is 0, 1. Right here is the same point. That's the 1, 0. So you have the 0 and 1 switch. They flip the x and y. That works for all the points there. Alright, you can also find the inverses algebraically by performing the following steps. So step 1, write the equation as y equals. Step 2, switch all x and y. So that's what we've been doing for inverse. And then step 3, solve for the new y. So example 2 is find the inverse of f of x equals x minus 3 over 5. So the first step is write it in y equals form. Changes f of x to y. So the same problem is y equals x minus 3 over 5. Step 1's done. Step 2 is switch the x's and y. So this y turns to an x. This x turns to a y. Everything else is the same. And the final step is solve for the new y. So this new y is part of a fraction. To get a fraction, you multiply the denominator. I'm going to multiply both sides by 5. 5 times x is 5x. Right side, the 5's cancel out. It's just y minus 3. Y is almost by itself. I got to add 3 to both sides. Remember, the 3 and the 5x do not combine. So this is just 5x plus 3 equals y. That's my answer. Now we should put it in the correct format. Remember, this is the inverse. So we're going to say the inverse, f negative 1 of x, is 5x plus 3. Alright, and lastly, when given two functions, you can figure out if they're inverses by 3 different methods. The first one's graph each and see if there is a reflection over y equals x, but that's a lot of work. Second is similar to what we just did. You pick one of the two and algebraically find its inverse by doing those 3 steps and see if it matches the other function given. That's pretty easy to do. And this third one's kind of new. You perform a composition of the two, both ways, and see if they give you the identity function. Meaning f inverse of x should give you x, and if it's both ways, f negative 1 of f of x should be x. So really think about it for a second. Inverses are just reflections where you flip things. If you have something, you flip it, then you flip it back, it's back to its original form, in this case x or whatever number you want to plug in. So I make a quick chart and I'll do a better problem that might make sense in the next part. If I have something called f of x, alright, it'll have plug in some x and y. For example, with this problem, I'll say I plug in some x, I get a y answer. Then I find its inverse. So let's call this f of x, and I'll call this f negative 1 of x. Alright, remember it's reverse. So basically, y will go here and x. I just flip the points. See that the x comma y turns to y comma x. But let's try to figure out this one real fast. Should be pretty easy. I want to find f of f inverse of, I'll do y for now. You'll see why I do y. Alright, so basically I'm plugging y, get something, now plug that answer into the next one, get something, and see what happens. So from before, you should know that f of f negative y is the same thing as f of f negative 1 of y. Remember, the y only goes to the rightmost thing. If we plug in y for f negative 1, we pretty much look at this table right here. By plugging y, I get x. So this turns into f of x. So now I have to go to equation f, plug in x right over here, and see that turns into just y. So see how I plugged in y, f of -1 of y, I got y back. This works for numbers as well, any letter, but you should get the original thing back. Again, you're flipping something and flipping it back. So probably this next example will make it a little easier to understand. Be able to identify if two functions are inverses. So f of x equals x plus 10 over 8, and g of x equals 8x minus 10. Which are the two inverses? We have three options. I could graph them and check if they reflect over y equals x. I could pick one. For example, this one's pretty easy. I'd pick this and calculate its inverse. So let me do that real fast, because I like that. I'm going to write it as y equals 8x minus 10. I'm going to switch x and y. Then I'm going to solve for y. So I got to add 10 to both sides. All right, and I guess I should show this half steps for y'all. Remember, those don't combine. And then I got to divide by 8, both sides. So this is just x plus 10 all over 8 equals y. And is that what the other one is? Yes, it is x plus 10 all over 8 equals that y, or the f of x. So yes, these are inverses. So that's one option. That was method number 2. Now I'm going to do method number 1. So let me do like this. Let me group that. So this is method 2. All right, method 1, I'm not going to graph. I'm doing method 3. We're going to do the composition. We're going to try f of f inverse. Now, actually, if it's inverse, so instead of f, they actually called it f and g. So instead of f inverse of x, in this case, it's called g. So let's use that. So we're actually checking if f of g of x equals x or not. Equals x. So let's check that out. Well, you know f of g of x means f of g of x. All right? So I'm going to plug in, I'm going to go to equation g, plug in x. If I go to equation g, and I'll do it on this side right here. Let's do it right down here, since I did it before. I'm going to do g of x. This means go to equation g, plug in x. So this will be 8x minus 10. I can't do anything to that, so I found that. So this is not going to plug into here. So this turns into f of 8x minus 10. So now we have to figure that out. So we're going to go down here. We're going to find f of 8x minus 10. So let's plug that in, go to equation f. And where x, I put a 8x minus 10 there. So on top of the fraction is 8x minus 10 plus 10 all over 8. So I'll work on the top. Negative 10 plus 10 cancel out to 0. So this is 8x over 8. And those 8 cancel out, it's just x. All right, so you see I plug in x to the original, and it came out as x and then. So this did match this right here. So I did that. I got to try the reverse. I got to do g of f of x. All right, so pretty much same idea. Let's see. So this should equal x as well. We check it. That again is really g of f of x. So I'm going to figure out what I'm going to do the f of x part first. If I go to f of x, that means go to equation f, plug in x. That's just x plus 10 over 8. Can't do anything to that. So that's going to go to the inside. I'm going to replace f of x with the x plus 10 over 8. So this turns into g of x plus 10 all over 8. Let's do that problem next. G of that fraction x plus 10 over 8. So equation g, plug in for x. So that is 8 times x plus 10 all over 8 minus 10. The nice thing is these 8's cancel out. 8 times that fraction 8 all over 8 cancels out. So this is just x plus 10 minus 10. Well, the 10 minus 10 cancel out, so it's just x. Alright, so that is true. This did match that. Alright, so if I were you, I'd pause this here, because that is pretty much the full video. I do want to try one more thing to show y'all something. I will do this, I'll erase this, so hopefully you pause that and get that. Let's try this. Let's figure out what f of g of, let's do 6 is. Alright. Remember, these are inverses. If they're inverses, remember, you plug something in, you flip it, you flip back, you should get the original. I should get 6. So y'all know that means, like before, f of g of 6. So let's figure out what g of 6 is. G of 6 means, go to equation g, plug in 6. So 8 times 6 minus 10, that is 48 minus 10, that's 38. So I'm going to plug that in. So this turns into f of 38. So now we got to figure out what that is. So I'll go over here. Let's see what f of 38 is. So go to equation f, plug in 38 for x, 38 plus 10 all over 8. Well, that's just 48 over 8, which reduces to 6. So this turns into 6. You see how when I plug something in, when I flip it back, I get the same answer back? So I plug in 6, I know I get 6 back. Alright, so as always, I leave you all with the practice problem. Here are two functions. Are they inverses of each other? The answer is no, they're not inverse functions. You could do the composition, graphing, or I'd just pick one and try to find the inverse. So for example, I wrote down here the real inverse of f of x should be x minus 3 over 2 and not that 2x minus 3. Alright, if you have any questions, make sure you ask me in class. But thanks for watching. See you in class. Bye.